D is all about all three forms of linear equations. So far, we've just talked about our slope-intercept form, y equals mx plus b, but there are two other forms, and we want to be able to convert between these two forms and also be able to graph depending on what form we are looking at. So we have our standard form, our point-slope form, and again, of course, our slope-intercept form. Just a reminder, slope-intercept form gets its name because just by looking at it, we can identify that slope, which is m, and our y-intercept, which is b. Our standard form is ax plus by equals c, where a, b, and c are real numbers. So these would be integers if we were looking at a problem. In order to be able to graph this type of equation, we first need to convert it into that slope-intercept form. Point-slope is the third form of linear equations that we're looking at. Y minus y1 equals m times x minus x1. Point-slope is called point-slope because in order to write it, or just by looking at it, you can see your slope, which is still represented by m, and a point from your graph, represented by x1, y1. So when we're looking at a problem, x1, y1 would be numbers, but our y and our x would remain variables. So let's take a look. On the left-hand side, we have our point-slope form, and we want to be able to convert it into slope-intercept. Notice point-slope, again, it gets its name because just by looking at it, we can use our x1 right here, and our y1 to find or to know that we have the point -4, 3 on that line, and our -2 is our m, so that's our slope. If we want to be able to write this in slope-intercept form, we are going to distribute and then solve for y. All right, distribute and then solve for y. So let's start off by distributing or multiplying that -2 by everything in our parentheses. Well, y minus 3 does not change. -2 times x is -2x. -2 times a +4 is -8. And then we need to add 3 on both sides here. Well, those cancel each other out. Y equals -2x minus 5. That is our slope-intercept form. Notice how that slope, -2, stayed the same. Didn't matter which form we were in, our slope was the same thing. So keep in mind that when we're looking at three forms, they are just different ways that you can write or represent the same line, the same graph. Okay, so we have two different ways, our point slope and our slope intercept. They look different, but they represent the same graph. Let's go over to the right-hand side and look at our standard form. 2x minus 3y equals 9. In order to write it in slope-intercept form, we just need to solve for y. We had a whole section in Unit 1 where we looked at equations like this and rearranged them so we had y isolated. So we're going to need to subtract 2x from both sides. That cancels each other out. -3y equals -2x plus 9. Remember, -2x and 9 are not like terms, so we can't combine them any more than that. Well, we still need to divide every single term by -3. These cancel each other out. Y equals, well, our negatives cancel each other out. So we'll have a +2/3 x. A +9 divided by -3 is -3. So our slope-intercept form is y equals 2/3 x minus 3. So essentially, when you are trying to convert something into that slope-intercept form, you are solving for y. That's kind of what this boils down to. Solving for y. All right, let's look at converting point slope into slope-intercept. So this time we have to write the equation. So they gave us our slope, which again is our m, and this point. So 4 would be x1, 3 would be y1. Remember that point slope form is y minus y1 equals m times x minus x1. You want to get very familiar with these three different forms. You are going to need to know these. And now we're just going to plug in the information into the correct spot. So our y1 is 3, our m is 1, our x1 is 4. So let's go ahead, plug those in, and we will have y minus 3 equals 1 times x minus 4. So this is our point slope form. That's all we need. Okay. And again, to convert it into that slope intercept, we are going to distribute and then solve for y. So we need to distribute that 1, which will leave us with y minus 3 equals x minus 4. Well, we still need to add 3 to both sides, and that will leave us with y equals x minus 1. So all we did was distribute and then solve for y to get that slope-intercept form. Sometimes you start with 2 points. So when we start with 2 points, first we need to find the slope before we can write that point-slope form. So remember, we're going to use that formula where we take the difference of our y's and we divide it by the difference of our x's. So we're going to subtract our y's, divide it by whatever we get when we subtract our x's. So I'm going to let this be x1, y1, this be x2, y2, and plug them in. I'll end up with 6 minus 7 divided by 4 minus 2. And when we simplify that, we will get negative 1 divided by positive 2. In other words, m equals negative half. That's our slope. Now we have enough information to write the point slope form. So I'm going to look at the point 2, 7. If I'm looking at 2, 7, that means that 2 is my x1, 7 is my y1. And we're going to, again, plug that information into our point slope form. Well, y minus 7 equals negative half times x minus 2. All we did was plug in our m, and then we used one of our points to plug in our x1, y1. We could have used the other point. So let's look at what happens when we use 4, 6. Well, now 4 is our x1 and 6 is our y1. So we'll get y minus 6 equals negative half times x minus 4. So it didn't matter which point we used. Either of these are acceptable answers for your point slope form. Okay, again, these represent the same line. They just look a little bit different because they are using different points from that line. And if we want to find that slope-intercept, we are still going to distribute and solve for y. So let's take a look at y minus 7 equals negative half times x minus 2. So we distribute and we get y minus 7 equals negative half x. A negative half times a negative 2 becomes a positive 1. We add 7 to both sides, and our slope-intercept form is y equals negative half x plus 8. That is our slope-intercept form. Okay. We could also, if we wanted to, we could have used the other equation. So let's take a look and see if we use y minus 6 equals negative half times x minus 4, what's going to happen. So again, we're going to distribute to start off. Y minus 6 equals negative half x. Negative half times negative 4 is a positive 2. We need to add 6 to both sides to isolate y. Y equals negative half x plus 8. Well, look at that. It didn't matter which point slope form we found or which point slope form we used. We still ended up with the exact same slope intercept form. Again, that is because these three equations are point slope forms, and our slope intercept, they all represent the same line. Let's take a look at our standard form. So if we're given something in standard form and we want to be able to graph it, we need to put it in that slope intercept form first. Okay, so remember, that boils down to just solving for y. So 2x plus 4y equals 16. Well, let's add 2x out of there. So we're going to have 4y equals negative 2x plus 16. Need to divide every single term by 4. So y equals negative half x plus 4. And there we have our slope-intercept form. Okay, we spent time last week learning how to take something in our slope-intercept form and graph it. So just by looking at this, we can identify our y-intercept. So that's our 0 and then b. So b equals 4 in this case. Okay, remember our y-intercept is always going to have 0 as its x value because that's how what it means to be on the y-axis. So following that logic, to be on the x-axis, the y value has to be 0. In order to find this, we can just plug 0 in for y and then solve for x. So we would get 0 equals negative half x plus 4. Well, subtract 4 on both sides. Negative 4 equals negative half x. Remember, now we want to use that reciprocal. So if I have negative half, I'm going to multiply this by a negative 2, because negative 2 is the same as negative 2 over 1. Okay, well, these are going to cancel each other out. So our x-intercept, whatever negative 2 times negative 4 is, leaves us with the 0.80. Let's graph that. Notice how 80 is in fact on our x-axis. Okay. Well, now we do have 2 points, so we can just connect these points for our line. We could also use our slope, so let's take a look at that very quickly. Our slope is negative half, so that would make our rise negative 1 and our run 2. So we would, of course, go down 1 and to the right 2. Down 1 and to the right 2. Down 1 and to the right 2. Okay. Notice how when we do that, we do still end up graphing that same x-intercept. So we have at least 2 points. To graph this line or to end this problem, we just need to connect all of our dots or all of our points. Okay. So that is the line y equals negative half x plus 4. So we've looked at our point slope form, our slope intercept form, and our standard form. You should start familiarizing yourself, start memorizing these 3 forms and their differences.